In the previous video lecture, we have seen about dynamic memory access interfacing with 8086 microprocessor. So in this video lecture, we will see about keyboard and display controller interfacing with 8086 microprocessor. So first of all, we will see what is keyboard and display controller. So this IC number is 8279. So generally, we will interface this keyboard and display with the 8086 or 8085 microprocessor using 8255 IC. So do you remember what is 8255? So it is programmable input output IC. Do you remember that we use such IC 8255 to interface the input and output devices with the processor. So here in general, in the starting of these connections, they were using this 8255 to interface or to connect the keyboard and the display with the microprocessor. So when we connect in such a way, what the processor will do is it will often look into the keyboard whether a key has been pressed or not. So for example, that point is called as polling. So this we have discussed while we are seeing about interrupts itself. So what it will do is, when a keyboard is connected with the processor, often it will look into the pin where the keyboard is connected to check whether a key has been pressed or not. But by doing so, the processor is wasting most of its time to ensure whether the key is pressed or not. So to avoid such situations, to avoid of the CPU utilizing more time in ensuring the key has been pressed, these kind of ICs has been used. So the 8279 is used in place of 8255. This 8279 will ensure all these functions of the keyboard and display that has been interfaced with the processor. Fine. So what this 8279 will do is, it will incorporate all the functions of the processor for ensuring the keyboard and the display functions. So this 8279 will control the functions of the keyboard and display by setting its modes, getting value from the keyboard, giving it to the processor, and then the processor will send the data to the display through 8279. So this is how the operation will happen. By doing so, most of the functions of the CPU is now incorporated by the 8279 for only ensuring the function of keyboard and display. So now the processor is relieved from all the duties of ensuring with the keyboard and display, and it will work on its main function or main program what we have assigned for that processor. So that's the main use of 8279. So in this video lecture, we are going to see about the architecture of 8279, what all the blocks are inside it, how it's functioning, and the modes of operation of 8279. So this 8279 is having two segments, one is keyboard segment, another one is display segment. So this 8279 is capable of accessing the input and output simultaneously. So when it is accessing the input device, it has to change its mode to input. So when it is accessing the display, it has to switch over to output mode. So often it will be switching to input, output, input, output. So whenever you are accessing keyboard, it will switch on to input mode. So keyboard itself is having three modes. We will discuss it later. And display mode, display segment is also having two modes. We will discuss it in later. Fine. So this I told you, here you are having two segments, keyboard segment, display segment. So keyboard segment will scan the keyboard for what key is pressed. So if the key has been pressed, it will send those keys characteristics to the CPU. That's the purpose of keyboard segment. So on display segment, it will get the data from CPU, okay. So and it will send to the display unit. Fine. So these are all the segments of 8279. So keyboard segment, I have already told you, it will scan the keyboard, detects the key and transmit to CPU. That's the purpose of keyboard mode. So display mode, it will get the data from the CPU and sends to the display device to display the particular character. So now we will see to the architecture of 8279. So as I have already told you, this 8279 is having two segments. One is keyboard segment, another one is display segment. Fine. So this is what the architecture of 8279. So in this architecture, this part is for keyboard and this part is for display. So display device, fine. So and here these part will be connected with the microprocessor, fine. I will explain each and every part now. So this part is meant for keyboard. So here RL0 to RL7 are known as written lines. So these are the input lines, fine. So this will get the data from the keyboard, okay, along with the shift and the control key. So I will tell you later why this shift and control are used. Now you just remember that. So from the written line you will get what the key has been pressed along with the shift and the control key, okay. So once the key has been pressed, it will go into debounce, keyboard debounce checking. So what is key debounce is, once the key has been pressed, so the processor, that means the 8279 will wait for 10 microseconds, that is for 2 scan time period. So 10 microseconds, which means 2 scan time period, to look into whether the pressed key, the key has been pressed for that time or not. So within that time, if the key has been pressed for 10 microseconds, the key will be recognized, fine. So that looking for 10 microseconds is called key debounce. So if that key is pressed for 10 microseconds, that key will be recognized and the key code, remember that key code. So key code will be stored in the RAM memory, FIFO RAM, first in first out RAM, okay. So this is how will happen. So written lines will have the key with the shift and control keyword, okay. So once this has been recognized, it will be checked for 10 microseconds whether the key is pressed for 10 microseconds. If it is pressed for 10 microseconds, the key code will be recognized and stored in the FIFO RAM. So from the FIFO RAM, the processor will get the key code, okay. So so here the RAM is used to store the key codes, fine. So the RAM status is indicated here by this block. So if the RAM is full, okay, if all the RAM space, consider that if all those RAM space is filled with the key codes, okay, an error flag will be set by the 8279 and it will be indicated to the processor. As I already told you, all these blocks will be connected with the processor. This section is directly connected with the processor, okay. Once the RAM is full, an error signal will be sent by 8279 to the processor to indicate that the RAM is full, okay. So by seeing to this error flag, the processor will start to fetch the data from the RAM memory, okay. So this block will tell you the status of RAM memory, okay. So on this block, control and timing register will, okay, so this will set the mode of the keyboard and display. So keyboard is your input, display is your output. So to set the modes for keyboard and display, the control and timing registers are used, okay. So this is an 8-bit register, okay. This is used to fix the modes for keyboard and display. That's the purpose of this, okay. This is the part of keyboard, okay. And then now we come to the display, okay. So this display, the key has been recognized and it will be sent to the processor. From the processor you will get the key what has to be displayed on the output display unit, fine. So you will get the character through data buffer. It will be stored in the display RAM, okay. Those characters from the processor will be stored in the display RAM, okay. So the address of the particular character will be stored in the display address register, okay. So here in this RAM we will store the key codes that has to be displayed, okay. The last accessed key codes address will be stored in display address register, okay. Then from there we will the character to be displayed will be given to the display register. So from that, through the lines output A0 to A3, out B0 to B3, the values will be given to the display device. Okay, this is what will happen, fine. And then this input and output control will decide whether we are giving the data to the buffer. Okay, the data in the buffer are given to the display or to set the command register to define the modes of these two devices, fine. So if you are writing and reading will be indicated by this read and write bar signal, then chip select to enable this 8279 and A0. Chip select and A0 will decide whether I am reading or writing. So that will be decided here. CS bar and A0 will decide whether I am giving the data to the display RAM or to the command register. So that is decided by the A0. Okay. So this is what the explanation for the whole 8279 architecture. So as I have already told you, here you are having two segments, keyboard segment, display segment. So from the keyboard you will get the values, that means key codes from the written lines along with the shift and control key, fine. So this will be checked for 10 microseconds whether the key has been pressed for this time period. If it is set for that means press for that time period, the key will be recognized, then the key code will be stored in the FIFO RAM. Okay. So if from the FIFO RAM the processor will get the data. If the RAM is full, an error signal will be given to the processor to indicate that the RAM is full, fine. And this control and timing register is used to set the set the mode for this display and the keyboard segment. Okay, the modes we will discuss later, fine. So there comes, and this will indicate the status of this RAM, fine. And then the IO and control unit will set whether read and write operation is performing and whether the data and the buffer is given to the display or to set the mode of these two devices, fine. And then this block is meant for display, fine. So the value from the processor will be stored in the display RAM. The last accessed data's address will be stored in display address register. Okay. So then the data from the RAM is given to the output device through the display register. Okay. So this is what the explanation for 8279 architecture. So this is the pin diagram of 8279. So this is the pin diagram of 8279. So as usual we have our VCC, then ground is VSS, our clock signal, RL written lines, RL0 to RL7, then data lines, data display blank lines, this is our output, fine. Chip select, A0, then scan lines, okay, shift control line, this is the interrupt line. IRQ is nothing but interrupt. So this will be set whenever a key has been recognized to tell the processor that a key has been recognized, fine. Then the reset line, read bar, write bar, fine. So I have already told you this IRQ will be set at when each time a key has been recognized, fine. So this they have termed here, what they have termed in the sense, so this line goes high whenever there is a data in FIFO RAM. So as I have already told you, once the key has been recognized, the data will be stored in RAM. So whenever data is stored, an interrupt will be generated. So now we will see the operating modes of 8279. So as I have already told you, this is having two segments, one is keyboard, another one is output, that is display segment. So keyboard is input now, that is having three segments, and display is output, that is having two modes, fine. So the first we will see about the input keyboard mode. Okay, here we are having three modes. One is scanned keyboard mode, scanned sensor matrix mode, and third one is strobed input mode. So this is meant for input, and for output you are having display scan mode and display entry mode. So first we will see about this input mode one by one, then we will discuss about the display mode. The first mode of input is scanned keyboard mode. So the scanned keyboard mode is interfaced with the 827 is interfaced using encoded or decoded scan. Fine. So what will happen here is, here you are having two concepts. One is 2 key lockout, n key rollover. Fine. So scanned keyboard mode, there when the 8279 is configured in the scanned keyboard mode, whenever key has been pressed, each and every key will be recognized and the key code will be placed or stored in the RAM. From the RAM, an interrupt will be generated to indicate a key has been pressed to the processor. Once the process is to that interrupt, gets the data from the RAM, and then it will process and then it will return to the display. So this is what will happen. Okay. So here you are having two concepts. One is 2 key lockout and then n key rollover. So we will see what is 2 key lockout now. Fine. So what is 2 key lockout in the sense? So if an user by unknowingly presses 2 keys at the same time, what the 8279 will do is, it will recognize only one key and not the other key. Okay. So what will happen at initially is, if a key has been pressed, it will check for the debounce period. That means it will check for 10 microseconds whether that key is pressed or not. So if the key has been recognized for the 10 microseconds, the process will be same as we said earlier. The key code will be recognized, stored in the RAM, and it will be indicated to the processor through an interrupt. So this is what will happen regularly. If 2 keys has been pressed simultaneously, one key will be recognized, another will not be recognized. So that is what 2 key lockout. Fine. So initially what it will do is check for the key has been pressed or not. If another key has been, so it will check for a key has been pressed, it will check whether another key is pressed at the same time. If another key is not pressed, it will check for the space in the FIFO, since we have to store the key code in the FIFO. If the place is there, it will place the key code along with the shift and control key. Okay, then an interrupt will be generated. Okay, so now we will again come to this place. If a space is not there in the FIFO, an error flag will be set, that will be sent to the microprocessor. This we know already. So again we will come here. If another key is also pressed at the same time, it will check for 2 scan period. Okay, so if only one key is pressed, then it will send to the FIFO RAM, or else another key will be ignored here. So that's why it's called as 2 key lockout. Only one key will be recognized. Okay. So this is what will happen. So it will check whether only one key is pressed or not. If more than one key is pressed, that key will be ignored, another key will be stored in the RAM. So now I will say you why shift and control key is used at every time. Okay. So you will see in a keyboard, you will have all those alphabet keys, your number keys, and at the top you will have your function keys, and above the numerical keys you will be having a special characters. So if you want to display the special character, you are supposed to use Control Shift plus that number to display the special character. Fine. So this is what you will do if you want to have a special character. So at that time, if you follow the 2 key lockout in the sense, so if now we are pressing Control Shift and a numerical value, so 3 keys we are pressing at the same time. So in 2 key lockout mode, if we set in the sense, so these keys will not be recognized and you will not be able to display the special characters. So at that is what the need for all the time we should represents the Control Shift key. That's why at each and every time the key code will be recognized along with the Control Shift keys. So if we use this 8279 in 2 key lockout mode without this control and shift recognition, when we are displaying the special characters, it will not be recognized since 3 keys are pressed at the same time. So if we make this as a must, control shift in all the key codes, in all the modes, so in the 2 key lockout mode, this will not be an issue here. So that's why on each and every time when a key code is recognized, shift and key is also being recognized. Fine. Okay. So on the next mode of scanned keyboard mode is N key rollover. Okay. So N key rollover, in the sense, before we have seen only one key is recognized, another key will not be recognized when 2 or more keys has been pressed at the same time. In N key rollover, all the keys that we have pressed is recognized in the same way that has been pressed. So that's the logic in N key rollover. Okay, fine. So what will happen is, when a key has been pressed, the key code will be stored in the RAM. So once it has been stored in RAM, it moves to the next key that has been pressed, and it will be another key will also put in the FIFO RAM. So this action will continue until this RAM is full. So if the RAM is full, an error signal will be generated to indicate the RAM is full to the processor. So if the process sees this, or if the processor recognize this RAM is overflow, it will take the value. What means the processor will take the value from RAM. Okay. So and an interrupt will be generated every time when a key code gets sensed. So this is what for N key rollover. So this is not the case for 2 key lockout. There only one key will be recognized, but here in N key rollover, all the keys that has been pressed will be recognized, and it will be stored in the FIFO RAM until the RAM is full. Okay. Once it is full, it will be indicated to the processor, then the processor will get the data from the RAM. So this is for N key rollover. So when we will set this N key rollover, rollover in the sense, if we want to use more keys for typing and all, we will go for N key rollover. So on the next mode is scanned keyboard special error mode. So what this special error mode is used only in the N key rollover. Fine. So here the debounce is inhibited. Debounce logic is inhibited. Okay. So why debounce? You already know that when a key has been pressed, it will be checked for 10 microseconds. So that operation is called debounce. Here the debounce is inhibited. So when this special error mode is used, in the sense, while if you see in your car, you will be having, in the audio system, you will be having your volume rise or low button, right? So that you will be pressing it for more times, fine, in order to increase the volume. So there, if you use the debounce means, so it will be recognized only once. So when you press 2 times, the volume has to be increased from 20. If the volume at the starting stage is 23, if you are pressing 2 times, it should be increased to 25. If the debounce has been used there, in the sense, it will be recognized only once. Okay, then the volume will be increased to only 24 and not to 25. So at that period or that case, we will use this special error mode, where whenever the key has been pressed continuously, since the debounce is inhibited, it will be recognized the number of times it has been pressed, and the operation will be performed in the same way. Fine. That's the purpose of special error mode. So simultaneous depression will be considered when the error flag is set. Fine. So on the next mode is scan Sensart matrix. So here your keyboard will be considered as like a matrix and will be interfaced with your 8279 directly, and the concept and the values of the rows and columns will be directly stored in the RAM. Okay. In the previous case, the key code and the key will be recognized and it will be stored in the RAM. But here in this case, Sensart matrix mode, the keys will be arranged in the rows and columns. Fine. So the rows and column detail of a particular key will be stored in the RAM. So there is a difference between these two things, keyboard mode and Sensart matrix mode. Fine. So the row and column values and the column details, row and column details will be stored directly in the RAM. Fine. Okay. So whenever a key has been pressed, that I have already told you, IRQ will go high. Fine. So when a key has been read from that RAM, IRQ will be reset. So that's the concept here in sensor matrix mode. Okay. So I already told you sensor RAM bits contains the row wise and column wise status of that keyboard. Okay. So on the next is output mode, that I have already stated. You are having display entry mode, display scan mode. Okay. In display scan mode, multiple displays will be organized in dual 4-bit or single 8-bit. So that is for scan. And here in display mode, you are having two things, right entry, left entry. So in display, we can display the data from right to left or else from left to right. So can you able to visualize the thing when it is displayed from left to right and right to left? So can you able to give an example for such device where the display is from left to right? Do you remember? The calculator. So in calculator, when you press the numerical values and then the arithmetic keys that you want to perform, so that will be displayed from the right to left. So left to right display, your monitor. So those kind of devices are example for that. When you see your monitor, the characters will be displayed from left to right. Fine. Another example for right to left is your LCD monitor. When you see your LCD, you will be using for the experiments, right? So where the characters has been displayed from right to left. So in left entry mode, the data entered from the left side. In right entry, it will be entered from the rightmost of the display. Okay. So this will start from the address 0 to address 15. So address 0 will be having the LSB, and this will be having address 15 will be having the MSB. Okay, this will be like you are writing in your notebook. Fine. So if this will be having the 0 will be having the MSB, and 15 here will be having the LSB. Okay. So if 15 characters has been used, if you are entering the 16th character inside, the previous value that has been displayed, this value, okay, will be shifted to the left, and the 17th entry will get lost since a new character is getting into this display. But here it won't happen. The 17th character is again displayed at the leftmost display position. No problem here in left entry, but there is a loss of data will occur in the right entry. Fine. So auto increment will happen. So whenever a character has been entered in this right entry mode, the first character will be displayed here, second character, third character. So automatically the address will be incremented. So auto increment mode is available in left entry mode rather than in right entry mode. So these are all the details and the operating modes of 8279. Okay. In next class we will see about PIC microcontroller.